Okay, GAP Math students, this is a video for Intro to Geometry, objectives 1 through 4. So you should, if you don't have it, you should go grab your packet that has the cover that looks like this. Okay, and what we have today is, I wouldn't say it's a hard section of objectives, but there is some notes we have to take. If you take good notes, the test will be pretty easy. Okay, so turn into the first page. We're going to be looking at these 4 objectives: line notation and relationships, angle pairs, missing angle in triangles, and classify angles in triangles. So throughout this packet, we're just going to be looking at the basics of geometry. We're not going to get into doing proofs and looking at theorems and postulates, and even if those words mean anything to you, we're just going to get the basics that you would need either for a job or a standardized test or something like that. So before we look at these first 2 problems, we're going to slide down below this problem and maybe just make a line here. And I'm going to put some notes down here. If you can't fit all the notes where I'm putting them, just do it on the back side of a different sheet of paper. I think there's a little area at the end of this section that's open. But we're going to go through some terms and draw some pictures and just get things, get some introduction to some of these terms and things like that right now. So the first one we're going to look at, so we're going to name some different types of angles and what angles are and things like that. So the first type is a complementary angle. Okay, and what that is are 2 angles that add to 90 degrees. So this can be done in 2 different ways. Okay, so if we have, I'll try to do the best I can in drawing. If we draw a little square in there, that means it's a right angle or 90 degrees. Now we're going to split this up into 2 angles here. So let's say, and we're going to name the angles. And sometimes you just can name them with a number, and I'll show you that in a second. A lot of times they use letters. And the way you name an angle is the middle, you'll use 3 letters, and the middle one has to be the one that's on the point or with the vertex. So A, B, D is an angle, A, B, C is an angle, D, B, C is an angle. So let's say this was 30 degrees, and this is 60 degrees. Okay, well, complementary angles, we'd say angle ABD and angle, and we can either name this one DBC or CBD, but it just has to be the B in the middle. So DBC, these would be complementary because they add up to 90. Now they don't have to be together, form an angle, they can be separate. So if we had, oh, that's an ugly angle, let me redo that. So if we had this, we'll call that angle 1, and that's 40 degrees. And we had another angle that was 50 degrees. Call that angle 2. So another example here would be angle 1 and angle 2. If at all I get going too fast on these, hit pause, copy them down, okay? So that's complementary angles. They add up to 90. So very similar. We're going to have supplementary angles. And they're going to add to 180. Okay, so another example. Straight line would be 180. Okay. I'm trying to do this as neat as I can, but this writing utensil isn't the best. Okay, so we'll put some letters in there. Let's say this is 60, and this is 120. So angle EFH and angle HFG, so this angle and this angle, those are supplementary because they add up to 180. I could also have it like this. Let's say this is angle 3. And let's say it's 135 degrees. Let's say we have an angle 4 here, that's 45 degrees. Well, 135 and 45 add up to 180. So another way we can write this is angle 3 and angle 4 are supplementary. Okay. Another term, adjacent, just means basically next to. If you have adjacent angles, they're next to. So like angle ABD and angle DC, or sorry, DBC, they're next to each other and they kind of go together to form one bigger angle. Those are adjacent angles. 1 and 2 are not connected or together, not adjacent. Okay. Angle EFH and angle HFG, those are adjacent because they are next to each other and form one bigger angle. 3 and 4, not adjacent. Okay, a linear pair. Means together form a straight angle or line. So a linear pair would be, like we looked in the other examples, EFH and HFG. If you put those two together, this straight line is formed, which equals EFG. Okay, so a linear pair also would add up to 180. Okay, just another name for them. 180 degrees, which 180 degrees is half, or a straight line, which is half a circle. We're almost done here. We got one little group. Again, if you run out of room, go ahead and write it in a different place if you can't fit this one here. And then we'll go do some problems after this. So we have J, we'll name that K, and L, M. Okay, so the next, what we have are called vertical angles. And these are angles that would be across from each other at an intersection. Okay, so J, K, N and so if that's this angle, across from it would be its vertical angle. Okay, and you can name it either way. I'm going to go kind of in a mirrored fashion, LKM. Okay, or if we had this angle, so I'm going to do two lines showing that it's NKM. And two lines here, LKJ. Again, it doesn't matter as long as the K is in the middle. Those are vertical angles. Okay, and the other thing we know about vertical angles are congruent. So let me try respelling that. It looks sloppy there. So CONGRUENT. Congruent. Okay, so that means, and congruent means equal or the same. So JKN, and this is a congruent symbol. It's like an equal sign with a little squiggly on top. It's congruent to LKM, and angle NKM is congruent to angle LKJ. That. Now, I won't get into really why they do this in geometry, but when they start talking about, so we just know those angles are congruent. Now when we put numbers to them, so let's just say this was, we'll use kind of one in the beginning, 60, 120, 60, 120. This will mean the same thing. If they say the measure of angle JKN, and then they say is equal instead of congruent. We won't get into a big deal with that. Oops, there'd be a measure there. Or measure of angle NKM equals measure of angle LKJ. So that's kind of a lot of stuff to begin with, but those, again, if you need to hit pause, write that stuff down. It's going to be the basis of a lot of the angle stuff. There's a couple other things we're going to go over, but the rest will go pretty fast. Okay, so now if we go here and look, again, like I said at the beginning, if you have the notes, your test won't be too hard because you'll be able to just look at this. So it says here, the measure of the complement of an angle is 61. What is the measure of the angle? Okay, so you know complement is adds to 90. So we want to do, we can either say something plus 61 equals 90, or you could just be thinking, well, that means if I take 61 from 90, what does that equal? Okay, and that would be 29. And that's your answer. Okay, so a question like that, you just got to check the definitions. Okay. Number 2, it says in a figure shown the measure of angle AED. So let's find that. AED is 122. Okay. Which of the following statements is false? Okay, so we gotta look at the one is wrong. So it says measure of angle AEB. It says that is 58. So what we gotta check, these form a linear pair, this should add up to 180. And if we add those together, it does. So that's true. It says angle AEB and DEC. So AEB and DEC are congruent angles. They're vertical angles. They're both 58. That would be true. Okay. And then it says measure angle BEC. BEC is 122. Well, it's a vertical angle to this one. So that is true. So the one that should be false is this last one. So let's check it out. Make sure. Again, this is just knowing your definitions. BEC and CED are vertical angles. No, they are adjacent angles that form a linear pair. They are not vertical angles, so that is false. Okay. All right. Number 3. So here's a type of problem we haven't talked about yet. When two lines have these across two different lines like that, that means those are parallel lines. Okay, or never will cross. Okay, so they'll just keep going this direction and this direction, never cross. Okay, now when you have parallel lines, okay, if any lines that are perpendicular to those parallel lines, so right here they draw a right angle. If two lines are perpendicular to the same parallel lines, then those lines are also parallel. So we're not going to get into a huge thing in this, just remember it for now. This isn't one of the biggest things you'll ever have to know. But it does make sense. If this is perpendicular to this line and so is this, perpendicular means form a right angle, okay, then these two lines are going to be parallel. So let's look at what it asks. It says which statement is true? DE, this means parallel, okay, so this is parallel. This means perpendicular. There's an R in there, that's hard to see. Perpendicular, okay, which means adds to 90 or equals 90. Okay, so DE, which is right here, DE and FG are parallel. Well, they cross. They cross right here. So that's false. They can't cross if they're parallel. CE is perpendicular to FG. So CE is this, and FG is right here. Well, it tells us right here those are parallel, so they're not perpendicular. So that's false. FG, so from here to here, is perpendicular to BC. Okay, so that I believe is going to be true if you look at it, because it looks like it is, but then let's take a look. We know BC is perpendicular to AE because they draw the square. And if this line is parallel to this line, that relationship's got to stay true. So this is going to be true. And if we didn't know that, we could look at the last one. BC parallel to CE. BC parallel to CE. No, they connect right there. They can't be parallel. Okay. So we're not going to dive deep into all those definitions of that one, but looking at the process of elimination there, you should be able to get that one figured out. Okay. Just a quick some notation on lines and segments and rays and what's the difference are here. Okay, before we answer this question. If you start with a dot and then have an arrow, and let's say we name this XY, this would be ray XY, and that's shown by having just an arrow on one edge. Okay, now there's specifics here. This cannot be YX. Sometimes you can go either direction, but the dot end is on the X and the arrows on end is on the Y. It has to look like that. A segment would start and end with a point. So this would be segment, and we would write that with XY with just a line on it, no arrows. Okay, and then the last one has arrows on both ends. And again, segment could be either way. You could have XY or YX. This would be line XY or YX, and it would have arrows on both sides. Okay, so if we look at number 4, it stops on one end and has an arrow on the other, so it's going to be a ray. So right now we can cross out A and B. It's not a segment or a line, it's going to be a ray, and you just have to have it, the stopped end is the B, the line end or the arrow end is the A, so it's going to be letter C like this. Okay. All right. Only a few more things we got to go, and then we'll kind of skip through and do some different problems. We're not going to do all of them. Oops. For number 5, thing we have to know about number 5, another basic thing, and a lot of you probably know this. The angles in a triangle add to 180 degrees. So here it says find the missing angle. So a couple ways you could look at this. You could say, you could write it this way. Okay. Or if you're thinking, well, if you start with 180, you take away the other two. Or you could add the 45 and 53 together first. Oops. That would be 98. So either way, you take the 180, you either subtract 98, or you would go 180 minus 45 minus 53. Either way equals 82. So the missing angle here would be 82. Okay, so we won't do it all the ones that we see in the packet here that are like that, but that's the key there, is that the measures of a triangle need that add up to 82. Okay, again, we're doing probably more problems in this one than we normally would do, just because there's different types of problems, but we're not going to do every one. Number 6, which is the best description of perpendicular line segments. So perpendicular lines would be two that go like this and form a right angle. We got to say what's true about this. Okay, lines that do not intersect, that's false, that's parallel lines. Okay, line segments, or so lines that do not intersect. Okay, B is line segments that do not intersect. Well, we're talking about line segments, so the first one should be false no matter what. It talks just about lines, and I drew this wrong then. I didn't read it complete. Line segments means there's no, let me redraw it. There's no arrows on these. So line segments means it would look like this. So we'd have a line segment, kind of a dot on each end, a point, I mean, on each end, and they're perpendicular. Okay, so line segments that do not intersect, no, those would be parallel line segments, so that's still wrong. Line segments that intersect to form a right angle. That is what that is. That is the correct answer. And then this one says lines that intersect to form a right angle. So you got to be really careful because this would be right if this just said lines and not line segments. Okay, so you just got to be careful with that. All right, number 7 says, what is the measure of angle X? So when you look at this, we know the measure's got to be 180 in this. Okay, so you might look at this and say, well, they only gave us one. Well, remember this little mark down here means that is 90 degrees. Okay. One thing we know in this problem, if you have a right triangle, the other two angles have to add up to 90 because the whole thing has to add up to 180. So you can never have two angles in a triangle over 90 or over. So we know A and D are out. Okay. So there's two ways you can do this. If you know this is 90, you can either say all of them have to add up to 180, or because you know this is 90, you could just know that the other two have to add to 90. Okay, either way. And then you just solve this, you subtract. You'd either take 180 minus 90 minus 56, or you would take 90 minus 56. They're going to give you the same answer. Either way, you're going to get 34 for your answer. Okay, so again, the triangle ones, they just got to add up 180. I just wanted to go over number 8 here because it's very similar to number 6, but this one says, what is the best description of perpendicular lines, not line segments? So actually, I don't think I'm going to answer this one. I'm going to let you do it and check your answers when you do it and make sure you get the right answer. So the biggest difference here is number 6 said perpendicular line segments. This says perpendicular lines. Okay, so I'm going to let you answer that one on your own. Check the answers in the back. Number 9, I'm going to let you do on your own. Number 10, find the measure that's supplement to angle AOC. Well, I'll just go over this quick. Supplement, if you look on the first page and we took notes, means adds to 180. So that means we're going to have something plus 56 equals 180. So then you're going to solve that. So you're going to take 180 minus 56, okay, and you're going to get 124. Okay, so anytime complement means they're going to add to 90, supplement means they're going to add to 180. Okay. Number 11, we got to talk about because we haven't talked about classifying angles yet. Okay, so angles and triangles. So I'm going to write some words here. Obtuse. If we're talking about an angle, or if we're talking about a triangle, what it's going to mean. Means obtuse means an angle bigger than 90. If it's an obtuse triangle, has one angle bigger than 90. It can't have two angles bigger than 90 because then it would be more than 180. If it's an acute angle, it means smaller than 90. Acute triangle, all angles are smaller than 90. Okay. A right angle equals 90 degrees. A right triangle has one angle equal to 90 degrees. And a straight angle, there's no straight triangle, a straight angle equals 180 degrees. Okay, so it says classify a triangle with the measures 105, 55, and 20. Now you don't have to draw this or anything. It has one angle over 90, so it is an obtuse triangle. Okay, all right, we're almost done. It's getting a little long, but there's just a lot of definitions and stuff here. Number 12, okay, that looks like it would certainly be 90 degrees. That's a right angle. Okay. 13, we're going to give you definitions of these type of triangles. Equilateral, before we look at the actual question, all sides are equal. So the triangle had sides of 5, 5, and 5. Okay. Isosceles, two sides are equal. Means like if you had sides, if two of the sides were both 10, then it's isosceles. So far this question was, what is the best classification for a triangle with sides 3, 6, and 7? Well, none of them are equal, so it can't be equilateral triangle. It can't be isosceles because you have to have two. Okay, a right triangle has a 90-degree angle. Now, that doesn't talk about the sides at all, and there's a way that you can figure that out knowing the sides, but let's hold off on that right now and let's see if D makes more sense. And we could figure out if it has a right angle or not, but we're gonna skip over that for right now. So this has a 90-degree angle. A scalene triangle just means it has no equal sides. Now, without doing any math, we can just look at this. There's no equal sides. 3, 6, and 7. That's your best answer. Okay. 14, we've talked about that one. You should be able to do that on your own. 15 is a complement problem. You should be able to do that. 16, I'm not going to do it for you, but I'm just, actually, we did one like that already. Just remember when you're doing that this is 90. I'll just give you a hint there. This one is a little tricky. I'll just help you out on this one just so you know. So first word needs to describe this one. Second word needs to describe this one. Okay. And I'm going to choose, it looks like this one is equilateral. Okay, so I'm going to cross off these two. Okay, now I could maybe give some leeway in a question like this if it was on a test, because it's really hard without showing measures to know for sure. Scaling means none of these sides would be equal. Well, it kind of looks like these two sides are equal, but we don't know that for sure. If these two are equal, then it's an isosceles and it's not a scalene. I think more likely it looks like this is a right angle. So this would be a right triangle. This would be an equilateral. I would answer D on that one. Okay, and I'm getting done here. I don't think there's many more I have to do. Just so I'll help you get started on this one. What is supplementary to DOE? So DOE is this angle. Okay, so we want to know what angle is going to go with that to add up to 180. Okay. And there's a couple different answers that would be on there, but only one is listed as a choice. So try that one, check your answers. If you're not getting it, just like any other ones, ask. You can do that one. 20, I was just going to help you figure this one out. It comes down to being a triangle problem, but let's go about how to figure this one out. Okay, now this angle is actually on the outside of the triangle, and there's not a measure here or here to go with to figure out. Like if we knew this, we know they're vertical angles, they'd be equal. Or if we knew this one, they'd add up to 180. So what we need to do is kind of go a roundabout way of getting this. So what we're going to start with is figure out if we knew this angle, then this and this would add up to 180. We could find a missing angle here, but we don't. But so let's start with this one. This is a linear pair with this. So we can find that angle by taking 180 minus 127. Okay, so if we do that, that's going to equal 53. Okay, so that means this angle is 53. Now the reason that helps us is because now this, and this equal 180. So if we take 180 minus 93 minus 53, that'll give us the third measure of the triangle. So I'm going to go 180 minus 93 minus 53. That's 34. So that's 34. Now these are linear pairs, so we know these have to add up to 180. So I'm going to take 180 minus 34. 80 minus 34. That equals 146. And that's what that angle would be right here. Okay. I think that one's fine. Number 23, I don't think I'm going to do the whole thing for you, but I'm just going to, when you get a problem like this, it might help to draw a picture. Now your triangle doesn't necessarily have to make sense. So you can just draw any old triangle. And it doesn't have to be super accurate. So I didn't even look at this. I just drew, it's going to be triangle ABC. Measure of angle A is 13. Okay, that probably looks bigger than 13, but big deal. Measure of angle C equals 67. Okay, now you can go about like another problem. I'm going to let you finish that problem. Knowing that they add up to 180, you can finish that. Okay, and then one last problem. I'm going to let you figure that one out. Look at the answers in the back, see if you understand. It's like one we did earlier. And if you have questions, you let me know. So that got a little long. Again, it's not super hard stuff, but if you don't have the notes, it's going to be. Okay, so just copying these notes down is going to be worth quite a bit of points because there was a lot of notes on this one. Okay, especially right here. Okay, so you can earn a lot of points just copying this down. Then try the other problems I didn't finish. Well, first send me a picture of the notes. So send me through chat on Teams. Then try the other problems. And then if you're not getting them, ask a question. And then when you finally understand, you need to ask for the test. Okay. All right. So again, if you have any questions, let me know.